On your Unit 5 big quiz number 2, we're going to verify this equation is an identity. Let's see, I'm looking at this. The left side looks more complicated, so I'm going to start on the left-hand side. So starting with the left-hand side, I start with sine to the 4th power minus cosine to the 4th power over sine squared of x. And my goal is to end with the right-hand side. So I get 2 equals 2 minus cosecant squared x. So don't write the whole equation, because then it's tempting to use that equation property and add or subtract or multiply on both sides. For example, like multiplying by sine squared would get that left side to be not a fraction, but that would use the property of equality, which we don't have until we're done verifying that it's equal. So you can write it at the end to kind of remind you that that is our goal, but it's not equal yet until we verified it. So our first step to try to simplify this left-hand side to make it look like the right-hand side would be to recognize that this guy, the numerator, is again a difference of two squares. Only the squares now being sine squared and cosine squared. And the reason I can write that is I know to factor that difference of squares. I can rewrite it like that. And then I didn't do anything to the denominator yet. One common problem I saw with this one is I'm going to write something that's wrong now. So I'm going to write it in red so you know that it's wrong. One common problem I see with this one is people wanting to cancel the sine squared with two of those. But you can't do that since that sine squared in the numerator is not a factor, it's an add-in. It's part of that subtraction problem. So since it's not a factor, I can't use division to cancel it. Since it's not multiplication, it can't be canceled by division. So that is something I cannot do. But I can do what I did on the right. I don't have any common factors. As you notice, the numerator has two factors with two terms each, and the denominator has only one factor. So there's no common factors to cancel here. Okay, so my next thing I can do, though, is recognize that I'll still use red because I'm going to cancel a little. This guy is really the Pythagorean identity, so that can cancel using the Pythagorean identity that says sine squared plus cosine squared equals 1. So I'm going to rewrite that with a 1 there, and having a 1 there as a factor, since that was a factor, doesn't really change the value of the equation to leave it off. So I'll leave it off. Again, I saw some people get to this step and then still wanting to cancel sine squared and sine squared. Again, you can't do that for the same reason as before. Sine squared in the numerator is not a factor, it's an add-in. So since it's not being multiplied, it can't be canceled with division. So that's another time we cannot do that. Okay, so what can we do? I can decompose this fraction. So there's not much else I can do with the numerator. Maybe this double angle identity. But I think our best route is to split this up into, so I can do some multiplication with that common denominator of sine squared x. So I'm going to split up that numerator, kind of undoing a subtraction problem. So it's easy to see from here that when you subtract these, you get this. So to decompose a fraction, you're undoing that process. So that decomposing that fraction is a very useful tool in verifying identities. so that you'll want that in your toolbox. But now I can, the nice thing about that is, and this is actually something you can look for, when you see something like this and you're tempted to make that cancellation, but you can't because it's not a factor, once you decompose the fraction, now you can. Because on the left fraction I have sine squared over sine squared, and that does equal 1. So I can rewrite that as 1. In fact, I'm going to write that in a different color so that I can use that as my step. Let's go with purple. So these will cancel and become 1. So in my next step, I can just write 1 minus, and then cosine squared over sine squared is cotan. And that is my ratio identity. So I have, I did two things there. In step 1, to make the sine over sine 1, that was just the identity property of multiplication. I'm not going to write that one. But the changing cosine squared over sine squared, that is the ratio identity. Okay, and then I think I'm getting pretty close. Remember, my goal is to get to this guy down here, and there's a 2 in there, and a cosecant. So I'm thinking, how can I relate cotan to cosecant? And how am I going to get that extra 1 in there? And I think, okay, wait, I do have an identity, another Pythagorean identity, that says cotan equals, I think it's actually written another way. I think it's written as I think you have to subtract the 1 from both sides to get this. I think it's actually written like this. And then we subtract the 1 from both sides. On this ID, you can use that the equal sign and move things around because this is already verified. So I can move things around on this to get this kind of version of, so I could replace that cotan. So I have another version of that Pythagorean ID, and I'm going to replace cotan with cosecant squared t minus 1. That's going to get me a cosecant. It's also going to get me an additional 1 in there. So I have cosecant squared t minus 1, and I still have 1 minus all of that. Be careful to note that you're replacing the cotan with that 2-term piece, so that minus sign, that's 1 minus cotan, that minus has to go to both those pieces. So that gives me, when I distribute that negative, I get 1 minus cosecant squared t, and that minus times the negative 1 gives me a positive 1, which gives me 1, oh, I'm sorry, kind of jumped ahead there. So a positive 1, and then when I add those ones, I get that 2 that I've been looking for, and I got my cosecant squared, which brings me this, and so that is verified.